Welcome everyone to a quick overview of Unit 3, Lesson 1 from Calculus, which is the chain rule. And the chain rule is one of the most useful derivative rules. It comes up whenever we have a composite function. So a composite function is defined whenever you substitute one function into another. So an example would be like this f of g of x I have written here. And how you take the derivative of that, what the chain rule is we're going to take the derivative of the outermost function first, so f prime, but we're going to keep the inside function the same. So f prime of g of x, and then I'm going to multiply that by the derivative of the inside function, this g prime of x. Now you may come across times where you have multiple functions inside of functions, kind of like the Russian nesting dolls, if you will. You just keep adding on more chains. So if g had an inside, well, when you took the derivative of g, you'd keep the inside of g the same and then multiply the derivative of the inside of that, and so on and so forth until you run out of chains. So I have prepared for us a mild, an easier question, and then two medium questions. And I also have a spicy question, a more difficult example that I'm going to go over in another video, just because it has a lot more intensity. There's a lot more algebra and trig rules you got to remember. So I figured that would just be best to be in a different video. So let's start with this mild question here. So we want the derivative of sine squared x. Now a common mistake my kiddos will make is they will not realize that this is composite. They'll think that they can just, the derivative of sine is cosine, so it's cosine squared x, and that's not quite how it works. So what I'm going to do is I'm first going to rewrite this as sine of x squared. So these two things are equivalent, and this way, what I've written in blue, you can clearly see the composite nature of it. The outermost function is something squared, and the inside function is sine x. And what I like to do is I like to write them down. The outermost function was something squared, and inside that was this sine x. The derivative of something squared by the power rule would be 2 times that something, and the derivative of sine x is cosine x. So the derivative here of sine squared x is going to be, the derivative of the outside was this 2. We're going to keep the inside the same, which was the sine x, times by the derivative of the inside, which was cosine. So 2 sine x cosine x would be the derivative there. So now I've got two spicier examples for us, because they kind of deal with rules that don't come up as often as some of the others, and especially with the medium 2, it's going to feel a little bit different. So here I think I can clearly see that the outermost function is 2 to some power, and the inside function for that would be 4x. The derivative of an exponential that's not e doesn't come up very often, so that's why I wanted to go over it. The derivative of an exponential that's not e is that exponential itself, again we're going to keep the inside the same, times the natural log of the base, which is 2. The derivative of 4x is 4, so when I put this all together, the derivative of 2 to the power of 4x would be 2 to the power of 4x times the natural log of 2 times 4. And we could clean that up, but that is essentially what it is. And finally, we have this secant. And the reason I chose secant is because secant has a really weird derivative. If I write these in order from outermost to innermost, we have secant on the outside and we have 2x on the inside. The derivative of secant is secant tangent. And both of those are going to get their own set of parentheses. We're going to keep the inside the same for both of them. And the derivative of 2x is 2. So altogether this would be 2 times secant, keep the inside the same, which would be the 2x, times tangent. And again, that's going to have again, that's going to have the inside of 2x. And that's really it. There might be a little bit more algebra involved, and again, I'm going to go over a spicy example in another video, but that is essentially it. The chain rule is take the derivative of the outside, you keep the inside the same, and times that by the derivative of the inside. Good luck with practicing with this, and I look forward to seeing you in the next video.